Atoms as building blocks of matter. Welcome to my presentation. I am Disha from class 8A. What is matter? Matter is everything around you. Matter is anything made up of atoms and molecules. Matter is anything that has a mass. Matter is also related to light and electromagnetic radiations. Even though matter can be found all over the you usually find it in just a few forms. All the matter in nature is made up of only a few elements. Elements are composed of molecules and molecules are made up of atoms. What is a molecule? Molecules are the smallest particles of an element or compound which has independent existence in nature. Then, what is an atom? An atom is the smallest particle of an element which shows all the properties of that particular element. So, atoms impart the properties of the element, whereas molecules impart independent existence. But how are molecules formed? Two or more atoms chemically combine together in a definite proportion to form a molecule. For example, the chemical formula H2O stands for one molecule of water. In this, H2 stands for two atoms of hydrogen and O stands for one atom of oxygen. Thus, to form one molecule of water, three atoms chemically combine in the proportion of 2:1. What is a molecule of an element? A molecule of an element is composed of atoms of the same kind. What is a molecule of a compound? A compound is a material or molecule made of two or more different atoms. For example, water is a compound as it is a molecule made up of hydrogen and oxygen. But the truth about an atom is that it is also made up of various other tiny particles. All the atoms of all elements are basically made up of protons and neutrons in the center, that is the nucleus, and electrons in the periphery circling around the nucleus. But the difference is that each element's atom has different number of protons, neutrons, and electrons in it. How does exactly an atom look? Let us see how an atom of helium looks like. This is an animation of a helium atom. A helium atom has two protons and two neutrons in its center and two electrons circling in the periphery. Now, let us have a look at a sodium atom which has more electrons orbiting around its nucleus. Let us see how atoms react with each other and form compounds.
Ionic bonding occurs between two atoms when one of the atoms has sufficient strength of attraction to remove an electron from the other atom. A sodium atom has one valence electron, with a stable energy level below containing 8 electrons. A chlorine atom has 7 valence electrons. If the atoms collide with sufficient energy, The chlorine atom will remove the electron from the sodium. The sodium atom loses its only valence electron and becomes a positively charged sodium ion. The energy level below now provides sodium with its stable octet. The extra electron completes a stable octet for chlorine, which becomes a negatively charged chloride ion. Covalent bonding occurs when neither atom has sufficient strength to completely remove the other atom's electrons. The atoms share electrons, and both atoms achieve a stable outer energy level. A hydrogen atom with one valence electron needs one additional electron to complete the first energy level. An oxygen atom has 6 valence electrons and needs 2 additional electrons to complete the second energy level. As the oxygen and hydrogen atoms collide, covalent bonding is accomplished by the sharing of electrons. By sharing an electron pair with the oxygen, the hydrogen completes the noble gas configuration of helium. By sharing with the hydrogen atom, the oxygen atom now has 7 electrons in its energy level, still one short of the stable octet condition. A stable octet for oxygen can be completed by sharing an electron with another hydrogen atom.
This is a movie made out of series of photographs of an atom using a stroboscope. Electrons moving in its orbits are visible. All these knowledge have been given to us by renowned scientists like Niels Bohr, Rutherford, Heisenberg, Pauli, and many others. However small these atoms and the subatomic particles may look, but these particles require huge machines for their study. These are called accelerators or cyclotrons. It requires unbelievable amount of energy to separate the atoms and subatomic particles from each other for their independent study. We recently had heard about LHC or Large Hadron Collider. Let us see a movie on LHC and end this presentation.